Welcome back, everyone. We are skipping ahead to lesson 7 of Unit 7. And in this particular lesson, we are simply going to look at some problems involving probability using the normal distribution. In the last lesson, we talked about the different characteristics of the normal distribution. Now we're actually going to solve problems using the normal distribution. And in order to do that, we're going to use this online calculator that I have posted here in the notes. So let's show you, if you click on the link, the calculator looks like this, and this is what we're going to use to solve all of the problems. All right, so with that in mind, let's go right into the examples. So, number one, estimate the proportion of LED bulbs. First of all, proportion is another word for probability or percentage. Estimate the proportion of LED bulbs that are expected to burn out before getting within one standard deviation of the mean before 2070 days. So to do that, we're going to go to the calculator, okay? And notice the first thing we're going to do is we're going to put in the mean and the standard deviation. So for LED bulbs, the mean is 2300 and the standard deviation is 230. So the mean is 2300 and the standard deviation is 230. And we want to know the proportion of LED bulbs that are expected to burn out before, and this is the key, before 2070 days. So before 2070 days, before is another word for below. So I'm going to choose below, and I'm going to type in 2070. Okay? And that's all I'm going to do. And I'm going to click on calculate. And notice I get the answer here of 0.1587. So that is the answer to number one. And that is literally how we're going to solve all of these problems here. So let's actually just answer all the ones having to do with LED bulbs. So we'll skip ahead to number 3. Now we want the proportion of LED bulbs that are expected to burn out after getting more than one standard deviation greater than the mean. So after 2,530 days. So when we do that, again, we're dealing with LED bulbs again. Okay, we're going to have the same mean and the same standard deviation, same mean, same standard deviation. The only thing that's going to change is the last part. So we want after 2,530. So I'm going to go to above, and I'm going to type in 2,530. Again, same mean and same standard deviation. And when I calculate, coincidentally, I get the same answer of 0.1587. So that is the answer to number 3. The next LED one is number 5. So we want to estimate the proportion of LED bulbs that are expected to burn out in the interval between one standard deviation less than the mean and one standard deviation greater than the mean. In other words, between 2070 and 2530. So between those two values. So on the calculator, I'm going to go to between, and I want between 2070 and 2530. I order those numbers from least to greatest. Again, same mean, same standard deviation. I just chose between this time, and I'm going to calculate, and I get 0.6827 as my answer to number 5. Okay. The next LED bulb is number 7. So estimate the proportion of LED bulbs that are expected to burn out in the interval between 2 standard deviations less than the mean and 2 standard deviations greater than the mean. In other words, between 1,840, 2,760. So same mean, same standard deviation, but it's going to be between 1,840 and 2,760. Okay. And I'm just going to recalculate again. And I get an answer of 0.9545. Okay. And then the next LED one is number 8. So estimate the proportion of LED bulbs that are expected to burn out in the interval between 1900 and 2100 days. So again, between 1900 and 2100 days. And I'm going to recalculate, and I get an answer of 0.1513. Okay, so those are all of the problems having to do with LED bulbs. The next set of problems have to do with incandescent bulbs, so the ones that we haven't done. So notice with the incandescent bulbs, I have a different mean and a different standard deviation. So now my mean is 100. So my mean is 100 and my standard deviation is 10. So for number 2, estimate the proportion of incandescent bulbs that are expected to burn out before getting within 1 standard deviation of the mean. In other words, before 90 days. So before 90 days would imply below, so click on below 90. And coincidentally, I get a similar answer to I got before of 0.1587. Okay. Jumping ahead to number 4, estimate the proportion of incandescent light bulbs that are expected to burn out after 110 days. So after 110 days would imply above 110. And again, I get the same answer, coincidentally, of 0.1587. Okay. Number 6, now we're looking for the proportion between 90 and 110. So between 90 and 110. So between 90 and 110. And I get 0.6827. Okay. And then the last one is number 9. We want to estimate the proportion of incandescent bulbs that are expected to burn out in the interval between 107 and 118. So between 107 and 118. And we get an answer of 0.206. Okay, so again, to find proportions or probabilities using the normal distribution, we're going to use that normal distribution calculator that was in the notes. And that is it for this lesson.